Okay, so in this video that starts out our next section on equations of planes, we're going to first revisit just some distance formulas, and both in 2D and 3D, and that's the that's the point line distance formula. And so finding the distance between a point and a line, I know it's something we cover in honors geometry, but that's been 2 years removed. So let me go ahead and give that to you to remind you of that, and we'll do a couple practice questions, and then really extend that to like a point in a three-dimensional line, which will help us define an equation of a plane. Okay, so in two space, so just x and y axes, right? So it says find the distance between the point 4, -7. So you have 4, -7 down here, and some line 2x minus 10y equals 4. And if you solve for that, and say, okay, well, 2x minus 4 is equal to 10y. Divide over the 10, we could see the slope is 1/5. And then divide by 10 minus 2/5 is equal to y. So we have an equation of the line that just kind of goes to about like this, and we want to know what is that distance. Well, I'm hoping you realize that although there's a couple, actually lots of different ways you can get from this point to that line, right? The distance would be the one that is defined to be the shortest length, or the one that is perpendicular. So that would be the one I'm looking for, right? Like if I want to know how far is this point to the line, it's not any path you choose. It's the shortest one, and that distance right there will always be perpendicular. Now, that's the distance that I'm looking for. And it's a formula that it's based on the distance formula, and so it's pretty, it's pretty nice to have and nice and handy. So your distance is equal to, make that a little smaller, the absolute value of ax plus by plus c divided by the square root of a squared plus b squared. Now, what are the letters? Where do they come from? So a and b would be the coordinates of your point. So your point is x and y. Is the point. So x comma y. So that part I think is always the easier of the two, because I can see an x there, I see a y there. I know that's x. I know that's y. The ABC come from the equation of your line, but you have to be consistent in what are you representing? What is the A? What's the B? What's the C? So it's when you're in general linear form. In other words, it has to be equal to 0. So this is the point line distance formula where x comma y is the point, and ax plus by plus c equals 0 is the line. And now that I have it in that form, I can make that association that the a, the b, and the c are the coefficients when set equal to 0. Okay, so now let's find that distance for our particular example. So in this case, I want to transform this slightly. Just subtract the 4, really. So 2x minus 10y minus 4 is equal to 0. And now when I could divide by 2 or -2, I could reduce. But I want to make sure the pairing, the parities, positives and negatives, line up. So then my distance would equal a, which is 2, times x, which is 4. So 2 times 4. Let me go ahead and just, I don't know, for some reason, it almost looks like a minus sign. So let's try that again. So 2 times 4 plus b, which is -10, times y, which is -7, plus c, so plus -4, all over the square root of a squared plus b squared. So 2 squared plus -10 squared, so 4 plus 100. So then we get 8 plus 70, so it's 78 minus 4. So I get the absolute value of 74, which is still positive 74, over the square root of 104. Now we could simplify. There's a perfect square of 4 inside that. It's 4 times 26. So I could say that's 2 root 26. And then 74 on top. Divide that in half, we get 37 over 2 root 26. Certainly we can rationalize that to get 37 root 26 over 52. Okay, so that would be the shortest length between the point and that line when we find that distance. Now, I could ask the distance between two lines, but there has to be hopefully an understood relationship between these two lines, right? The two lines have to be parallel. Otherwise, if the two lines aren't parallel, then your distance could range anywhere from 0, where they intersect, to infinity, where they are diverging. So we have to know that, oh yeah, they're parallel to each other. So and a quick check, if you wanted to simplify this, even just getting rid of the fractions, multiplying both sides of this by 4 would allow us to have 2x is equal to 3y, minus 44. Add the 44 across, so 2x plus 44 is equal to 3y divided by 3. And so then we get what y is equal to. Now, it's funny, instinctually, I went to slope-intercept, even though I know I'm going to have to go back and change it, but at least I know y equals 2/3 x plus 44/3. Like, I can really see that in terms of graphing, and then when I solve this by dividing by the 3, I get y equals 2/3 x plus 1. So I definitely see they're parallel. So I can find the distance between the two. Now, sometimes students have the idea here. So 2/3 x plus 1. So there's that, right? And then let's say 2/3 x plus 44/3. So definitely parallel, right? So this is 44/3 and this is 1/3. So sometimes they wonder, well, can't you just subtract, right? Can't you just do this to find that distance? And the answer is no, because that's not the shortest length between those two lines, right? That would actually be the hypotenuse of that. So we have to make sure that we realize we can't just subtract the intercepts unless your lines are running, parallel to the x-axis. Then that distance wouldn't change. So how do you use the point slope formula? How do you use the point line distance formula? Well, you have a point, and then you have then you have the other line, right? So you could pick any point on either line, and a lot of times it's just like based on inspection. So if there's something that you see that seems to be a nice point, pick it, right? And so like I'm looking at this equation here, and I'm thinking, okay, I know that negative 22, 0 is on that line. And, so again, 2 times negative 22 is negative 44. 0 minus 44 is negative 44. So I kind of found this one by inspection. And then I'm just going to use this equation for the A, B, and C. Of course, I'm going to remember to rewrite that in general linear form. So 0 is equal to 2x minus 3y plus 1, because I have to bring the 3y over. So now, again, just to kind of summarize, there's your x, there's your y, and then 2 is your a, negative 3 is your b, and your c value would be 1. Okay, so then we put it into the formula, which we know is distance is equal to the absolute value of ax plus by plus c, all divided by the square root of a squared plus b squared. So then we can put into our values. Our distance is a, which is 2 times negative 22, which was x, plus b, which is negative 3 times 0, and then plus c is 1, all over the square root of a squared plus b squared. So the square root of 4 plus 9. So then I get negative 44 plus 0 plus 1. So it's the absolute value of negative 41, which is 41, all divided by the square root of 13. Divided by the square root of 13. And so we could rationalize that to get 41 root 13 over 13. Okay. Now, much like last unit, measuring it in the third dimension just extends it one variable. So now my distance formula has 4 components in the numerator and 3 in the denominator. So now, my distance would be ax plus by plus cz plus d all over the square root of a squared plus b squared plus c squared, because you've increased the dimension. And so our point over here, that's your x, comma, y, comma, z. And then your plane would be in general linear form. So there's your A, there's your B, there's your C, and there's your D. And so, and again, like a lot, like this unit will start looking at planes and equations of creating planes. And, it's based on our first idea here of just measuring this distance by extending our point line distance formula one dimension. So then let's just go ahead and calculate this. So A, which is 2, so 2 times negative 1, plus B, which was 1, so 1 times 4, plus C, which is 3, so 3 times 2, plus D, which is negative 5, all divided by the square root of A squared, which is 4, plus B squared, which is 1, plus C squared, which is 9. So let's see, that's negative 2 plus 4, which is negative 2, plus 6, so that is 4, minus 5, so it's negative 1, so the value of that is 1. That's a 1. Negative 2 plus 4 is negative 2. Negative 2 plus 1, absolute value, yep. And then this is the square root of 14. So when rationalized, we get root 14 over 14. Okay. Again, just knowing that point line distance formula and extending it into that third dimension is really what we need to worry about for this particular, for this particular video.